This is Senior Algebra, Section 2.6, Rates, Ratios, and Proportions. Today we're taking a look at solving proportions through rates and ratios here. So the difference between a rate and a ratio here, a ratio has two like quantities. A rate has two unlike quantities. We both use them as a quotient. So for a ratio, that could be a distance over a distance, like feet over feet, or inches over feet. They're both measures of distance here. A rate would have two different units. Miles per hour. Okay, that would be the most common example here that when you think of rates here. So also below it says a ratio. We have it three different ways to write it. Most of the time we're going to write it as a quotient there, A over B like that, but you could write it the other ways as well. So let's take a look at example 1 here. We're taking the ratio 5 hours to 3 hours, writing it, and we're going to write it in a couple different ways here. One thing that we have to take a look at with ratios is that they really don't have units on it. So we're going to do some canceling out of units here. We write it 5 hours over 3 hours here. The hours are going to cancel out, so our ratio is just 5 to 3, or 5 over 3. And we could write it 5.3 there, 5 over 3, or 5 to 3. And again, no units there. The units have to cancel out on our ratio. In B, it says we have 6 hours to 3 days. It is important that we do write the hours and the days here. Notice I can't just simplify 6 over 3 here, okay? Because hours and days, while they're talking about some time quantity, they're not the same. So what I have to do is I have to change one of them. I have to have the same units here. So hours to days is probably going to be easier to change 3 days into hours here. If you remember back in chemistry, like unit conversions, it's basically what we're going to do here. So I'm going to take 3 days. I'm going to multiply it by the conversion here, which is 24 hours is 1 day. Days has to go on the bottom here because now days cancels out. And now I multiply across 3 times 24. That gives me 72 hours over 1, or just 72 hours. So I'm going to rewrite it 6 hours over 72 hours. The hours now are going to cancel out. And then I have 6 over 72. I should simplify that. So I'm going to divide the top and the bottom by 6. When I do that, I get 1 over 12 here. So that's my ratio there, 1 over 12. In example 2, we have a rate here. Right? We have two quantities. We have a price and a amount here. So price in ounces here. So this would be considered a rate here. One of the things that we do quite a bit here, and that you'll see in grocery stores, is a price per ounce. The unit rate, it's called. So we're going to look at our 3 different jars of peanut butter, the 18 ounce, the 40 ounce, and the 64 ounce. And we're going to figure out which would be the best per ounce, or the best price per ounce here, the lowest price for us. So if I want to figure out price per ounce, per means divide here, I'm going to do price over cost, price over amount here. So in the first one here, the 18 ounce, it's $1.50 over 18 ounces. When I divide 1.5 divided by 18, I get the cost as 0.083, and that's what? That's the price for 1 ounce of that jar. I'm going to do the same thing for the 40 ounce here and the 64 ounce. So 40 ounces is 414 divided by how many ounces it was? 40 ounces. I'm going to divide that. I get a cost per ounce of 0.104. So that's what, about 10 cents per ounce here. In the 64 ounce, I'm going to take the cost $6.29 divided by 64 ounces. That gives me a unit rate or a unit cost of 0.098. So about 10 cents, a little bit less. So if we look, the comparison here, okay, which is the lowest cost per ounce, that would actually be the 18 ounce, the smallest one. Doesn't always work that way. Typically we see that, the larger the amount, okay, the idea of buying in bulk here. So in this case, it doesn't happen to be the lowest. The lowest is the smallest container, the 18 ounce. In example 3, we're solving some proportions here. So we have kind of two kinds. In A, we have kind of the simple proportion where we just have to solve for x. Notice x is on top, so I'm going to multiply by 63 on both sides. In this case, the 63s are going to cancel out on the right-hand side, and I'm just going to be left with x. And then on the left-hand side, I have 63 times 5 divided by 9. Now, I could take 63 times 5. That would be okay. But I'm going to simplify 65 over 9. Well, that's 7. And then 7 times 5 is 35. In B is a more difficult problem here because we have a 5 on the bottom and a 3 on the bottom. We're going to have to get rid of both of those. So if I look, to get rid of the 5, I would multiply both sides by 5. But I'm going to take it one step further. I'm going to get rid of the 3 as well. So to get rid of the 5, I multiplied 5 on both sides. To get rid of the 3 on the bottom, I'm going to multiply by the 3 as well. So I'm going to multiply the right side by 3 and the left side by 3. Now, what happens is that when we do some canceling here, if we take a look, the left side, the 5s are going to cancel out. If I multiply by 5 and divide by 5, they're going to cancel out. On the right-hand side, the 3s are going to cancel out. So on the left-hand side, I'm just going to be left with 3 times the quantity, x minus 2. On the right-hand side, I'm going to be left with 5 times x plus 1. I just put the 5 out in front. Doesn't matter. At this point, it becomes a pretty easy problem here. I'm going to distribute. I'm going to move my x's over to one side, my constants over to the other. So I'm going to subtract 3x from the left side. If I do it from the left side, I have to do it to the right side. And I'm going to move the 5 over as well. So I'm adding 5, so I'm going to subtract 5 or add a negative 5. When I do that, I get 2x equals negative 11. And then when I divide each side by 2, I get x is negative 11 halves, or negative 11 over 2. I can leave it like that. If you wanted to make it negative 5.5, that'd be fine as well. Our last example, pumping gas here. So in this one now, instead of being given the proportion, we're going to have to create it. Keys when we're creating proportions is this. You have to be consistent with your units here. So I'm going to create a ratio, a rate or a ratio here on the left-hand side. The ratio or the rate that I'm going to use, actually it's a rate, is 1660 to 5 gallons. Now, it doesn't really matter what I put on top or bottom. I could go 5 gallons over 1660, but here's the important part. If I have dollars over gallons, on the right side, I have to have dollars over gallons. They have to be consistent there. So, as long as I have that, now I can fill in my other items here. The price that we're given is $48.14. The gallons, we don't know, that's our X here. So I'm going to rewrite it now without the units here. 16.6 over 5 equals 48.14 over x. At this point, I have an x on the bottom, which is a problem here. So I'm going to get rid of the fraction here. I'm going to get rid of the 5, and I'm going to get rid of the x here. So to get rid of the 5, I multiply by 5. If I do it to one side, I have to do it to the other. And I'm also going to multiply by the x. because that will get rid of it on the bottom. So now we look and we do some canceling here. On the left-hand side, the 5s are going to cancel out. On the right-hand side, the x's are going to cancel out. So the x's on the right-hand side cancel out. I have 5 times 48.14. On the left-hand side, the 5s cancel out. I have 16.6 times x. So 5 times 48.14. Let me do that in my head real quickly. Not really. $240.70. 1660. When I divide each side by 1660, x is going to be how many gallons I pumped, which is 14.5 gallons here. Make sure I do label it here. So the sentence I would write would be something along the lines of, how many gallons did you pump? You pumped 14.5 gallons, 14.5 gallons, something like that. Again, on a quiz or test, you will be expected to write a sentence explaining your answer.